Good evening and welcome to my channel, YouTube Pain Free Partha. Subscribe, listen, and enjoy. So today we are going to talk something about what are the types of data and what are the statistical tests involved in this. Which data, which test? What are the types of data? This is going to be very simple and many of the big professors will know this. Now, what is the data? Data is a qualitative or quantitative. Either it may be. Quantitative means what is amount like? 1, 2, 3, 4, 5, 6, 7, 8. Qualitative means yes, it is there or not there. What is the score? Like that. Qualitative. That are collected, measured, analyzed. It may be in numbers, text, images, or sounds. What it is used for informed decision making and analysis. This is what it may be in text also, images also, and sounds also. Informed decision making and analysis. Now there are quantities, information, graphs, measurement, observation, all these things. There is something called big data. What is this big data? An hospital can track thousands of patients' health metrics in real time to predict disease outbreaks. Okay. Now sometimes an epidemic of plague is coming. Something is coming. So an hospital, thousands of patients today, health things can be analyzed and say this number of our patients can develop plague. All these things. So they can personalize the treatment plans. This is what is called big data, which contains volume, variety, and velocity because it is a real-time update. There is something called primary data and secondary data. Now, primary data is the original data collected. That is what we are more important and we are looking at. We are doing some experiments. We are doing some surveys, interviews. Experiments means we do give ondansetron and check whether there is a decrease in nausea and vomiting. This is an experimental primary data. Okay. Now, accurate, fresh, but time consuming. It will take 3 months. There may be lab results also. Now, what is the secondary data? Now we have collected the data. We have given ondansetron and vomiting is less. We have given ondansetron and nausea is less. This is what we have collected as a primary data. Now this data is there. And now what we are seeing in this is whether there is less hypotension, whether this ondansetron is producing better hemodynamic stability. Already data is collected. Now we are doing something else, like census data, previous research studies. So this is what is called the secondary data, which is already collected. So it may be readily available, but may be potentially outdated because your data of ondansetron may be in 2020. Now what we are focused is about primary data only. We are going to focus on primary data. Now what are the types of data? Qualitative data means descriptive data. Nominal and ordinal. Quantitative data means discrete and continuous. It is a numerical data. This is a descriptive data. Qualitative is description. Good, fine, better, best. Descriptive data. Numerical data means 1, 2, 3, 4, 5, 21 plus or minus 5. This is numerical data. So descriptive data and numerical data. Qualitative is sometimes also called categorical data. Categorical, it is categorized. There is no 1, 2, 3, 4, 5, 6. Qualitative is also called categorical. Like I've already told, nominal and ordinal. What is nominal? That represents without any intrinsic ordering or ranking. There is no ranking. Patient is a male or female. Patient has been given GA, regional anesthesia, or local. This means there is no ordering or ranking. It is simply yes or no, male or female. This is what is called a categorical, qualitative, nominal data. Nominal data. Okay. Now, chi-square test of independence is the ideal test for this male, female. Okay. For example, now your male is 20 out of in group 1 out of 30 and female is 10. In group 2, male is 18 and female is 12. So it is 20 by 30, it is 18 by 30. This is what is called chi-square test. This is contingency table. That is what I told. Now there is a smoker and male, female. 30% smoker, 70% non-smoker. Female 20 and 80. Total is 100, 200. So this test tells that there is an association between the categorical variables. What is the categorical variables? One is male, another is smoking. Is there an association between male and smoking? Is there an association between female and non-smoking? This is what this contingency table chi-square test tells. Now we are telling nominal data, male or female, these things, the contingency table and chi-square test. We'll go to the next data. Ordinal data is also a type of qualitative data where the categories have a meaningful order of ranking. Okay, one, first rank, second rank, third rank, fourth rank, fifth rank, but the intervals between the ranks are not equal. First rank is not equal to the second rank. This is not, the difference is not one. First rank and second rank and third rank. Between 1 and 2, there is 1. Between 2 and 3, there is only 1. So this is not equal. Rank 1 and 2, the difference is different. That is what is called quantitative, categorical, ordinal. Ordinal data. Now I am telling you ASA physical status. ASA status 1, 2, 3. 2 and 3 is not equal to 3 and 4. Understand? This is what is called ranking data. Patients are satisfied, dissatisfied. There is some scoring systems, like that scoring systems. All these things forms the ordinal data. Now, what I have to test has to do for ordinal data? Analyzing ordinal data is two independent groups is Mann Whitney U test, and more than two groups is crystal values. Okay. Now I will tell you. This patient is not showing NRS, numerical rating pain score 11. Nothing. Mild, moderate, severe, he is telling. Group 1, Ramadan, how many mild are there? How many moderate are there? How many severe? In Petrin, mild, moderate, severe, how many are? This has to be done with Mann Whitney U test. But you have a 3 drugs, same mild, moderate, severe, moderate pain, and 3 groups, Tramadol, Petrin, and Flupertin. Then you have to go for crystal values. So ordinal data, which is part of qualitative or categorical data. Now, Mann Whitney U test for 2 groups and crystal values for 3 groups. But the data is categorical, it is ranking. Now we will go to quantitative data. That means it is a numerical one, number. Now if you come say number of patients coming for PAC. Some patients don't come for PAC, we see directly on TV. On coming for PAC, number of patients who go for cross consultancy. Here in discrete, there is no decimal. Number of cars which are parked in the car parking area. Number of students in +2 exams going from the school. So this is quantitative data, discrete, and there is no decimal, but we can add and subtract. Okay, 21 students of this class, 22 students of this class, 21 plus 22 total is 43. That we cannot do in ranking. This previously ordinal data. Are you able to understand? I'll come back again. So again, this chi-square test is the test for this. There is something called chi-square goodness of fit test. For example, now you are going to your one college and taking the blood group of that college students of 200 students. And here A, B, and O are there. But whether this is going along with the whole population, we should know. No. This college has got more of A and B rather than A, B, and O. All these things will be chi-square goodness of test. Is it going along with the general population? Is the sample match the general population? That is what is called chi-square goodness of fit test. Now we know qualitative and quantitative. Now we got some same thing. Number is there for ordinal data also. Number is there for discrete data also. This is quantitative. This is qualitative. Now see the difference. Data with a clear order but no fixed intervals. Countable data. Survey response, satisfaction levels, ASA status, number of students in a class, can perform meaningful arithmetic operation cannot be performed. Now, ranking survey, satisfaction level, 3, here it is 2, 3 plus 2, 5, cannot be done. So he can do addition and subtraction in this discrete data. This is qualitative, this is quantitative. Sometimes we'll be confused. This is also 1, 2, 3 ASA status. This is also 1, 2, 3. So this is ranking, that is number of status. Understand? There is a clear thing we can perform arithmetic operations. Addition, subtraction. Now we know in the qualitative we have nominal, ordinal. In the quantitative we have discrete data we have to. Now we have continuous data, discrete and continuous. Height, weight, distance. Now we have one study. Now for example, distance of the branching of the musculocutaneous nerve from the axillary. How many centimeters from that? Okay, how many centimeters is the IJV from the suprasternal notch? Something like that. Distance, mean arterial pressure, mean pain score, mean income. You are doing now. The mean pain score is 4.2 plus or minus 1.2, the standard deviation. The decimal will be there in continuous data. It is a quantitative data. It is not discrete. Decimal will be there. It is number of students correct. No, decimal 1.2 plus or minus 0.1. So decimal will be there in continuous data. Height, weight, distance, mean arterial pressure. Now if the blood pressure is 140 and it is coming to 130, a paired t-test can be done. To know more about t-test, we can go into my use and misuse of t-test in a different video of my YouTube channel, Pain-Free Partha. If you are doing for one-way analysis of variance, then 3 or more groups. Now, you have a BP of 130. Now you put a laryngoscope and endotracheal tube. Okay. Now the BP goes up to 139 millimeters increase. Okay. Now this is before and after. Same patient. This is parity test. Now what you are doing is you are doing dexmet for one group and control for one group, and you see the change. There are two groups when you do unpaired t-test. Analysis of variance is 3 groups: control, dexmet, and clonidine. 3 groups are there. So you do analysis of variance. This is a quantitative data and continuous data. Decimal is there. This is about use and misuse of t-test. Now I don't want mean age. Now I want median age plus IQR in quartile range. Same age, distance from the IJV to scale. If you are going median means 1, 2, 3, 4, 5, 6. What is the center number? If the center number is there, not there, then you can do one. The center 2. If you add and divide it by 2, that is median. Number of center. You create the data in a ascending order. Okay, that is median. Interquartile range I will do later. So this is what is Mann-Whitney test and Wilkinson sign rank test, because you are not using mean age. This mean is a parametric data. Median is a non-parametric data. I will come back again to it. Parametric data means the distribution is normal distribution. Height, weight, BP et al. T-test, ANOVA, Pearson correlations. Here it is Spearman rank correlation. Mann-Whitney test, non-parametric data, ranks, categorical data. Everywhere you have to do Mann-Whitney test. Requires normality, doesn't need skewed distributions. Come back again. Sensitivity, continuous data, ordinal, categorical data. These are parametric data and a non-parametric data. Non-parametric, we have to use Mann-Whitney, and parametric, we have to use t-test. What is the normal distribution? The graph is a bell shape. Now, the highest point of the bell peak is the mean. Okay, the curve slopes equally like this. Now you see that this is the mean, and the curve slopes like this. Curve slopes like this. Now, what we do is one standard deviation. For example, now it is this mean is 70. Okay, mean arterial pressure is 70. The first standard deviation is 3. Okay, here 3, here 3. 68% should come within this. Total sample is 100 means 68 people should be within this 67 to 73. Mean is 70. Standard deviation is 3. Okay. 67 to 73. Standard deviation 1, standard deviation 1 that side. Minus 1 standard deviation, plus 1 standard deviation. So it's 67 to 73, 68% to be there. Now we go to 2 standard deviation. 70 minus 6, 64. Here plus 6. 64 to 76, 95% is there, then it is a normal distribution. This is what is the normal distribution and a Gaussian distribution. Okay, if the data is only normally distributed, you can apply even in quantitative continuous data the t-test or ANOVA. If the distribution is not normal like this, then kurtosis are skewed, then we cannot do this parametric t-test or ANOVA. What to do? Normal distribution or not? Then we can do QQ plot. Now you see minus 2 standard deviation. Everything is there in this term. But here you can see minus 1 to plus 3. Here in this you can see plus 1 to minus 3 standard deviation. So then it becomes not much correct for parametric. There are a lot of tests which says Kolmogorov-Smirnov test which says yes, your data is normally distributed. Shapiro-Wilk test, if you apply to the data, it will say your data is normally distributed. If it is not normally distributed, then we have to go for non-parametric test. No t-test, no ANOVA. For non-normally distributed, non-parametric statistical test, Mann-Whitney test, Wilkinson rank test, or Krustal-Wallis test. Do not assume normalities. They are based on ranks. Now we also should know sometimes Pearson correlation can be used instead of t-test. Okay. Now if it is going to be continuous variables, we can do this without comparing means. Now hours of study and exam scores. Strong positive correlation. A medium positive correlation. There is no correlation at all. The data is here, no correlation. It's a negative correlation. It is a strong negative correlation. Okay. Hours of study and exam scores. Age going on, lipid LDL level is going on. You see here. Hours of study is in quantitative simple data. Okay. 3 hours, 4 hours, 4.2 hours, 5.2 hours. Continuous data. Exam scores is also continuous data. 3.2, 4.2. Exam scores is out of 10 you get 6, 6.3, etc. This is a continuous data. Okay, that is what is Pearson's correlation. Age and lipid. This is also a continuous data. Age is increasing, lipid LDL level is also increasing. So this is a strong positive correlation. Now, if you don't have this continuous thing, you have other non-parametric data, then you have to do Spearman correlation. Non-normally distributed data, skewed data, all these things, for example. Now here it is very simple. Height and weight, simply relationship between height and weight. Here you can see this fellow is a 3rd rank in maths, while 5th rank in science. While one fellow is 4th rank in maths and science. So this is ranking in maths and ranking in science. Is there any correlation? This is what is Spearman correlation. Both are non-normally distributed data. What is Bonferroni correlation? Correction. Bonferroni correction. Every time we say p-value is 0. Less than 0.05, fine. Statistically significant. No. Here, now we are using 3 techniques. In the mean spine score is 3. Here, p-value is 4.5, 0.3. Now, without corrections, you see this. However, using the Bonferroni's correction means it is 1/3 of it, 1/3 of it, 1/3 of it. Because we are using too many groups. If you do this Bonferroni correction, 0.05 by 0.3, this is 0.0167. Okay. The p-value of this only A is significant and B and C may not be significant. If you apply the Bonferroni corrections to this technique A of pain reduction, technique B of vein reduction, technique C of vein reduction. It may be technique A may be ibuprofen tablet, technique B may be acupuncture, technique C may be a psychiatric this thing. So this technique A of giving ibuprofen is better because we have done the born for an E correction. There is something called Tukey correction. It is used after an ANOVA test. So this is parametric data. Now you see, diet A has a mean weight loss of 10, diet B 8, and C Tukey's test. Now we find this A is better, B is better, something like this. We will go to some scenarios. Okay. Now example is nausea score. What is nausea score? It is a ranking. Okay. 1, 2, 3, 4, 5. Ordinal data. It is not nominal data. Yes or no? Male, female, male. Ordinal data. What is the test to be used? Man-Whitney test or crystal values. Age, continuous t-test for NOVA. Mean age is 35.5 plus or minus 2.5. This is t-test. 3 groups means ANOVA. When the age is divided, for example, 100 people are there, out of which 0 to 18 is 22, 19 to 45 is 35, and another 45 is above 40. Now, if you have divided the age like this, then the data is not continuous. It is ranking. Now, 1 to 18, 19 to 40, and more than 40. The data becomes categorical, ordinal, then we may need to use chi-square test for independence. And continuous outcome is not there, then we may not use this ANOVA. So this is what is the difference. Now, marital stage is single, married, divorced. Simple. Nominal data, qualitative data. Now you have to use the chi-square test. Don't drink or drink. Nominal chi-square test. Now we have blood pressure recorded as historic values. Heart rate at 75.5 plus or minus something. Oxygen saturation 98. Anesthesia duration 135 point. Dosage of anesthetic propofol 2.5 milligram per kg. All these things are quantitative continuous data. So we may need to use either t-test if they are normally distributed. So what is the number of items returned by the customers in a month? Feedback numbers. How many people have done the feedback? All these things form the discrete data chi-square test. The Fisher's exact test is a suitable non-parametric alternative for categorical data when they're dealing with small sample size where the chi-square data might not be appropriate. We can use Fisher's exact test. The mean dose of anti-epileptic is different from the two groups. The mean means continuous data. Two groups. So it is two groups is there. Unpaired t-test should come. Now, qualitative data, descriptive, nominal, Man-Whitney, and chi-square, and t-test ANOVA. Thank you all.